Okay, then. Well, welcome to Uplink number 17. We're just about to bring Dr. Mark McCorcoran in. One moment. Hello, Mark. Are you receiving?
I am, Alex. How are you?
I'm very well. Well, I delighted to see you again. Obviously, from a really lovely vantage point, I would say possibly one of the most emblematic scenes of all time playing out behind you, which is, I guess, a human artifact escaping our environment and going into another one. What are we actually looking back?
Well, as people who follow me on social media we know, we've been struggling with endless construction work in our own house and next door. So I decided to move to French Guiana. This is the Kourou spaceport, the Centre Spatial Guyanais, as it's called, where Arianespace and European Space Agency operate launches from. So we have three launches, and we're going to talk about another one a bit later on. The big heavy lift launcher is the Ariane 5, which you see behind us here, and that's lifted missions like Rosetta and Bepi Colombo into space. We also launch Soyuz rockets, the Russian, formerly Soviet rocket. Those are also launched from Kourou as well. And that includes missions like Gaia, for example. The same rockets are used to launch humans into space, but not from Kourou. And then the one we're going to talk about today a little bit with one of our guests is Vega, the small lifter that is the newer of the three. And then we have a new edition of that, actually, a new version being launched tomorrow. Vega Mission 16, VV16. And we'll talk about why that's different later on. Fundamentally, we're going to be launching 53 satellites tomorrow from Kourou. So that's really exciting coming up.
Well, it's an exciting moment, and I suppose we have two people know better to tell us all about what that's all about. One is a true expert in rocket science. The other, I suppose, a little closer to my side, although he's a phenomenal photographer, an observer of launches. And I guess we're going to ask him what the visceral feel is of watching. Before we bring them in, Mark, I mean, you've been to a launch once or twice. I mean, what is that experience like?
Well, some of the launches, it depends where you see them to some extent. And I've only seen launches from French Guiana, and there we're quite a long way away from the launch pad. It's a very big site in the jungle, effectively. And the Ariane 5 is a big rocket, big sound. The Soyuz is actually relatively small, and that's one I saw most recently in December, the launch of Chaos, our small exoplanet mission. Of course, the big things like the shuttle in the past, Saturn V, and so on, and the more modern rockets coming on, which will be even bigger. So there's already Falcon Heavy and the SLS, kind of even bigger than Saturn V coming up soon. So yeah, it's a visceral thing, again, depending on distance and depending on the size of the rocket. But it's also an emotional thing to watch something leave this Earth and go, jump so high effectively that it leaves, it's able to go into orbit or even escape the gravity of the Earth altogether if it's going fast enough. So there's something quite emotional about, as you said, humans building machines which can cast either themselves, astronauts, or their avatars, our robot spacecraft, out into space.
Indeed, it's an inspiring thing, and we're going to bring our experts in now. We're going to be joined by one alumnus of Space Rocks, Kate Underhill, aka Rocket Kate, which is fantastic, and Trevor, a new friend of Space Rocks. Hello, guys. Are you receiving?
Hi.
Doing
Yeah.
well, doing well.
Excellent. Good afternoon, everybody. Good morning to you, Trevor, in Florida. Yeah.
Indeed. Well, fantastic to have you both aboard. It's great. Yeah, Mark, you and Trevor are kind of like night and day. It's it's absolutely brilliant there. But I was just saying to Mark, Kate, how nice it is to have you back with Space Rocks. I mean, anyone who was at our last London event, I'm sure was absolutely enthralled by what you have to say. And you've got some very interesting artifacts behind you, I believe to do with the place that Mark was just telling us all about.
Yeah, this is actually my home. So I haven't done this just for you. This is actually the way I live. So this is our home office, and we've got Ariane 4, the good old rocket, European rocket, the previous one to Ariane 5 today, obviously on a advert for the Belle Cabresse run, which is a very important part of French Guiana and launch campaigns in general. And then we've got here on the Ile de Salut. So these are the islands just off the coast of French Guiana. This is where they had the penal colony. So I don't know if you remember Papillon, the book, the film, Escaping. So that was on l'Ile de Salut, including Devil's Island. And that's actually, we have one of our first tracking stations is on there. And the islands have to be evacuated every time we launch because we launch straight over the top of them. And there's only about 3 people that live there anyway. And then I've got a nice little poster, ESA, very, very nice ESA poster. And I do a bit of publicity. You get that lovely poster if you buy something from the ESA shop, like, what's this? This is a little ESA body for your space baby.
Fantastic. Very good. Well, you know, I guess I want to ask a really obvious question, but might not be immediately obvious. Why French Guiana?
Very good question. And then I've got the good prop for this as well. You may remember this.
Brilliant.
So, where is French Guiana? First question, I think. It's here, down in South America, next to Brazil, between Brazil and Suriname, which is Dutch Guiana. It is France. It's actually technically part of France. It's part of Europe. So as a European space agency, European rockets, we want to be launching from somewhere that's Europe. As you can see, it's on the coast of South America. So we can launch all over the Atlantic Ocean, and we can launch north or south, and we're launching over the ocean and not over people's heads, which for safety reasons is obviously a very good idea. We've got a lot of room down there. Rockets are obviously quite complicated, tricky, dangerous activities. So we need a lot of room for our different buildings have to be very separated. When we're moving things around, we need to be away from people. So we've got a lot of room to work down there. It's very geologically stable, not many earthquakes. Earthquakes and rockets are not a good combination. Same thing with hurricanes. We need to be able to ensure that we can actually operate most days of the year without having to run undercover because of huge tropical storms. And the final point is that it's near the equator. So as we all know, the Earth turns every day. And at the equator, you're going at 1,500 kilometers an hour already. So before you even take off, you're already going very fast. So it makes our lives a little bit easier when we try and get into space.
Now, I have to correct you immediately. You have to rotate the Earth the other way for it to make sense.
I was thinking you could throw the other way, yeah.
Yeah, because we launch in the direction that the Earth rotates, if possible. So hence the reason that we launch from Florida. Japanese can launch out over the Pacific Ocean in the direction that the Earth is turning, right? Although there are launch sites which don't do that, and I don't know, we'll talk about those perhaps later on.
Yeah, if you launch, if possible, you want to launch from the, as you said, the East Coast. You want to launch eastwards and get the most out of the Earth's rotation. So that's why, like you say, East Coast of America, of South America, of Japan, of China, good place to launch.
Yeah.
Well, I have to confess a level of envy because I think that I have by far seen the fewest actual launches, the sum total being 0, obviously not counting ones that I've watched.
Oh.
But I have a strong suspicion that Trevor may be in the upper tier in terms
does anyone have 37 beat?
Not on this call, that's for sure.
37 launches. I mean, what I'm so interested in here is there's a wonderful juxtaposition on this episode of Uplink, because you know, we have Kate as the pure science, you know, that is behind it, which we want to really delve into, and Trevor, I suppose, almost from an artistic reportage, but also just observational standpoint. I mean, you have seen these things go up, and Mark and I were just discussing at the top of this show, just the feeling that you get of watching, and not just what you're seeing, but what it all means. I mean, why don't you describe that for people like me who might be watching and literally have no idea but like to imagine?
I mean, every launch still feels like the first launch, so it's such an adrenaline rush, and the sound and the sight and everything sort of combined. And usually, if you're watching it from a public location, there's a lot of people there, so everyone's sort of taking it in at once. It's a sight to behold, and I've spent the last 5 years coming down to Florida from sort of the Midwest and the Chicago, Northwest Indiana area, and it's just been a labor of love for the past 5 years, and now I'm here full time to continue the coverage.
So would it be fair to characterize you as an addict, Trevor, perhaps?
Yes. Yeah.
But you've managed to monetize your addiction as well. I know it's not only through the launch photography, but also you're a broader professional photographer, right?
Yeah, absolutely. So the launch photography is what I do a majority of the year, and then yeah, so I'm here full time to continue the addiction.
It's it's interesting because some people might know that I come from a bit of a musical background. The world of magazines, rock and metal coverage and all that kind of stuff. And a lot of people think that it's easy to capture a rock concert. When in fact it's an incredibly unique skill. That takes a huge amount of refinement just to get the angles right. To kind of really capture the energy and all that. Trevor, I mean, I imagine it's kind of the same case for taking a picture of a rocket going up, because I guess this sounds obvious, but they move pretty fast. I mean, tell us a little bit about what the technique involved without giving away your tricks of the trade.
Sure, sure.
What does it take to produce an image like the one behind you?
So this one behind me was VA 250, and that was from French Guiana, like Kate was talking about. And we actually got to go see the Devil's Island the day before launch. So got to go do a little hike out there and see the lighthouse, which I'm also a fan of. Yeah, so it was cool to sort of see it because there's sort of two islands there, and see the sort of prisoner island and stuff like that from afar. Um, but just like here in Florida, there's a whole community around that. But more to the technicality, that like a concert, there's high, bright light and dark light, and trying to balance both of those, especially with like the rocket. You could see kind of here, it was just after sunset, so you're trying to balance, the brightness of the EAPs and the darkness of the night, and not blow one or the other out. So that's really the challenge. But the settings you use are, I would say, largely similar to a concert. So not too different.
I guess you probably win on the volume front, but and I guess the you could say the production is a little more expensive.
Yeah, right, right.
As-
Maybe an order of magnitude more, I would think.
one or two at least. One or two at least.
So Kate, when we see a rocket like that, you kind of see the noise, the thunder, the light all go. And Trevor just mentioned the EAPs, which you're going to have to pronounce in French, but are the solid rocket boosters on the side there, which help. So I mean, it's a concert in many ways. It's a symphony. There's lots of things have to work at exactly the right moment and literally in the right frequencies as well, because these rockets can shake apart the things which are packaged right at the top there. So, it's impossible in an hour. Give us a sense about, how do you even begin to design a rocket from the ground up, something like this?
Yes, it is rocket science. And like you say, in fact, rocket science, the basics are actually quite simple. But as you pointed out, the devil is in the detail. The point is that everything has to work perfectly together for it to work. And the smallest, tiniest little thing that doesn't work, then it's a very, very expensive problem. And so the very basics is, you need to get into space, and to get into space, you actually need to be going very fast. So you need to get up to about 8 kilometers a second. So if I just said from French Guiana, we're already going at 1,500 kilometers an hour due to the equator, but that's not near fast enough. And to get up to that speed, you actually you need a rocket engine. You have special fuel, so on Ariane 5 in the main stage is liquid oxygen, liquid hydrogen. As you said, on the side, it's solid boosters, which are a mixture of aluminium, plastics, and various additives, putting it together to make a very strong burning. And that gives us the thrust to get off the ground. And then it's a liquid oxygen, liquid hydrogen that are very, very, it's a very efficient reaction that's giving us the engine speed. The engine is pushing hot gas out one end and pushing the rocket forward in the other end. So these are the engines we need. And then our last kind of trick in the book we have to consider is what we call staging, which is where, because we have to be getting up so fast, we need so much to burn, so much fuel to get that fast. In fact, our rocket is so heavy at liftoff, what we do is separate it up into stages. So we have a big heavy stage, like these big boosters taking us off the ground. And in the case of Ariane 5, after 2 minutes, we've actually used them up. They're 260 tons of fuel each. So if you can imagine that gets burned up in 2 minutes, then we drop them, we drop the empty structure, makes our rocket a bit lighter. Then we go on to the next stage. And then the main stage on Ariane 5 burns for 9 minutes. And then we have an upper stage, which is again burning oxygen, hydrogen. And that gives us the last bit we need to get into space. So the basics are rocket engines and staging.
Now, let me pick up on that, because a lot of people will, you said, liquid oxygen, liquid hydrogen, both incredibly difficult substances to handle at very, very low temperatures. So, the cryogenic aspect of rockets is incredibly complicated. Bits of metal get very cold, pipes get cold, things fracture. But it's not the only source of fuel that you can use. So things like Soyuz and Falcon 9, for example, the main stages there use kerosene and liquid oxygen. So reducing, because liquid hydrogens are weird stuff, right? You can just escape out of almost anything unless you have a really strongly sealed vessel. And now is the move to methane as well, which of course maybe we'll come to with respect to other engines.
This is a huge trade-off you can do. So liquid oxygen, liquid hydrogen are the most efficient, almost the most efficient gases you can get. But as you said, liquid hydrogen, it's liquid at 20 Kelvin. So it's very, very cryogenic. It's very hard to handle. It's a very light gas. This is why we end up having really big gas tanks. Ariane 5 main stage is mostly hydrogen tank. If you take something like kerosene, you have a slightly less efficient reaction, but the kerosene is much easier to handle and the tanks are much smaller. So you have a smaller rocket, it's easier to deal with. And the same thing with methane, it's what we call a light cryogenic. And in fact, it's very useful because it's quite similar to oxygen. We can kind of manage it in the same quantities. So we get a slightly less performance, but again, we get an easier rocket to manage overall. So these are all the kind of trade-offs that people do when they're designing a rocket from scratch, depending on what they want to get in terms of performance.
Right. But you can't kind of go and change the fuel on an engine, right? No. You can't say, I'm just now going to put extra octane fuel in this one or that one. They're completely different engines from the ground up, right?
Yeah, each engine is very, very specific, and even an engine that's burning the same fuel. So, for example, the engines on the main stage Ariane 5 is a Vulcain on the bottom stage, and on the main stage, and it's a Vinci or HM7 at the moment on the top stage. They're both burning hydrogen and oxygen, but they're both completely different engines. And they're completely different. Vulcain is there to help us get off the ground, and the top engine is there to get us really precisely where we want to go into space. So they have completely different designs.
Well, I mean, the thing that's apparent from, I guess so much of, Trevor's work and just everything that we see is, I mean, it's not just like the vast amounts of things that have to go right, in a perfect sequence, but it's also, I mean, what strikes me is the incredible stress on materials that must take place, just in order to kind of contain that kind of, upward force. And so, I mean, how much have things evolved since, I guess, perhaps in a lot of popular imagination, I think the rocket that a lot of people think of, is something 50 years old, right? Just like thinking of like Saturn V and so on. How much has it indeed? How much has it evolved and moved on since then? Because I mean, there's such a wide variety of launch vehicles, going up for so many different purposes, like the one this week, which I guess you could say it's a bit of a space bus, isn't it?
Yes. So there's the Vega launch this week. That is, I don't know if that's one you're talking about, but Vega is launching the smaller, all of the area, or smaller of the European launch vehicles, and it's launching. It's tomorrow evening from French Guiana, so very early on Friday morning, with a total of 53 satellites on top. So that really is a Tetris of. I'm glad I wasn't involved in doing the integration of all those satellites. It's rocket, again, what I said, like the basics of rocket science haven't actually changed, and those equations, we've known them for over 100 years. Tsiolkovsky's rocket equation has been known for over 100 years. The basics are still there, and obviously the law of physics still apply. And that's the interesting point now, is what we're really working on is optimizing the engine cycles, optimizing some of the components, and really the materials, the metals, like you say. The metals we have for liquid hydrogen, it's at 20 Kelvin, and then a few centimeters later, it's being burned at over 2000 Kelvin. So there's this huge thermal stress on these materials. And this is where there's a huge amount of work that we're doing now. And this is where I'm working now on future projects. We're doing things now like 3D printing machines, 3D printing engines that can give us whole new forms that we couldn't make before. So before we were really constrained by how we could produce an element. And now with 3D printing, we're really much freer, and we can have different ways of cooling gas being put through the different components to really optimize the basic physics that's going on in there.
Right. So Trevor, you've of course documented many launches by SpaceX, Falcon 9 and the Heavy, and of course there's that whole move towards reusability, and there's a lot of, there's a degree of controversy about that, because to some extent you have to save on propellant to be able to bring things back, so maybe the rockets aren't quite as effective. But give us your take on that. You've seen those machines go up and down. You've seen the same cores go up and down several times, and it's how does that feel to you, having come into this field? Again, it's not something we want to sort of fight about here, but it is an interesting debate, right, about how we push rocket launches forward in this regard.
One of the interesting things is when we go to the launch pad to set up our cameras, it's fun to try and use the big zoom telephoto lenses to zoom in on the number and figure out sort of which booster it is that they're using. And in the past, couple of years, it was fun to sort of go through like the 30s and 40s. And of late, it has been like late 40s and early 50s for what feels like, 2 years or so. Like the first Falcon Heavy and the second Falcon Heavy were like 54, 55. And I think we just...
sorry, I'm missing something. 54 or 55 what?
Of the first stages. Oh. So the first stages are numbered.
Okay.
The side. And then, like the first Falcon Heavy, I think was 1048 or 1047. And then, of late, 1056 is the most recent booster, going on 2 years later. So, and they've done, I don't know the exact number, but they've done a significant number of launches, and there's only been, 8 or 9 sort of new boosters that we've seen. So I think that's something I've noticed recently more so is sort of the pace has slowed down as they've been able to log more flights,
right,
on sort of the old boosters.
Yeah. And you've also traveled, you in a sense, you're our avatar view into the new space industry that's going on. So you've been down to New Zealand as well to see Rocket Lab's Electron, right? That's an interesting location as well, I guess, right?
I've been fortunate enough to go there. I've been to Japan for an H2 launch. I've been to Kazakhstan to see a Soyuz launch crew to the space station, one of the fellow Boilermakers. So I've been fortunate enough to go several different places, but it's cool to see the new providers and technologies, sort of churning the pot a little bit. And
Yeah, I mean, I want to come back to Kate on that because, of course, Vega tomorrow is kind of going into that space. It's a small rocket launcher. These are, when we talk about 53 satellites, many of them are kind of this big, and there's 3 or 4 on top, which are 100 kilos or less. So these are small satellites. They're not intended to go to other planets. They're for low Earth orbit things. How do you see, from the perspective of, kind of us preparing future launches, where's the market? Is the market the big things which are going to take us perhaps to Mars? It's going to be a lot more stuff in low Earth orbit, or do we just need everything, all of those tools, because there's a plethora?
I think if I knew the answer to that question, I'd have a much higher pay grade than I do at the moment. That's part of the problem, is that the market is very dynamic, and what satellite's going to do in 3-4 years, people have predictions and we do have ideas, but nobody can really tell. The development time of a rocket, even if you're going really fast, and SpaceX did a good job, and we're doing Ariane 6 now in about 5-6 years, it's still longer than the time that the market changes over. And so there's a good saying, I think, from Arianespace, the commercial operator in Europe, is any satellite, anytime, anywhere. And I think that's a good motto to have for a launch provider, is that we need to provide all the solutions so that any satellite can come to us and we can say, yeah, okay, then we can put you on this Vega launch, or we can put you on this Ariane 5 launch, or we'll put you on the Ariane 6 launch when it's available in a few years' time. And that we have all those options, and we can take you into low Earth orbit, or polar orbit, or lunar transfer orbit, or out into the solar system in escape orbit.
Right.
So this is a really fascinating thing, because I think it might not be, completely apparent. So a commercial company can basically go in and schedule, a bit like booking a ferry or something. Just saying, okay, well, we can, we got the clipboard here, and we can fit you into, this early 2023 slot to take you up.
It's a delivery truck. Launchers are glorified delivery trucks. We're taking expensive packages up into space with a very, very high precision, because they need to go exactly in the right place. And that's part of the interest of, I think, the job of the commercial launch provider, is saying, well, actually, yeah, I've got this satellite going up to this orbit at this time. I can fit you in on that ride. And that's exactly the beauty of what Vega's doing now, is they found all of these small satellites that are going to more or less the same place. They've got upper stages going to do a few burns and deliver them to a few different orbits, and they can deliver them all in one go. And you take the same thing for geostationary satellites. Ariane 5 today will take up 2 communication satellites at the same time, and take 2 at the same time in the same place. So you have a kind of, you reduce the price because it's a kind of a, was an Uber shared ride. You know, you've got a taxi, but you're sharing it with a few other passengers as well.
Fantastic. Well, I mean, I to extend that and not to go too far off piece, but I just wondered, how is that possible to fit so many satellites onto one? I mean, I guess they all have to be pretty small.
This is exactly what Mark just said. So on the, out of the 53 satellites, I think there's 6 or 7 that are called micro satellites. So it's about 10 kilos to 100 kilos each. And the rest, it's 40 odd, what we call, you know, nano satellites. It's 1 unit or 2 units, which is 10 by 10 by 10 centimeters. So some of them, and again, this is a really interesting thing. These satellites that can come from universities, these are things that, you know, students can make and associations can make. It's not cheap, but it's definitely more affordable than your tens of millions of euros of communication satellite.
So let me pick on that, because we talked about SpaceX, and they're now of course launching Starlink satellites, and there's up to sort of 60 at a time of those getting deployed. I'm going to put Trevor on the spot here just a little bit. You're of course aware of the controversy, perhaps, particularly from the scientific community, about the potential for light pollution, that there's lots of these things going up. And I mean, I've seen them fly overhead right here, and certainly in their initial phases, they could be pretty bright. And that's kind of a concern perhaps for amateur astronomers who just want to look at the sky. But of course, there's the flip side, which people say, well, it's going to deliver low latency internet to the whole world. How do you see that from your perspective? How do you see the trade-off between kind of the common good, that this is a public commons, and a commercial company using the sky to serve a commercial market, which it is? I mean, it's not only for SpaceX, it's true for everything that we do, right? How do you balance kind of not public ownership, but a public stake in space with the commercialization?
Yeah, I mean, I think there's sort of a little bit of a give and take on both sides. I feel like it's doing a lot of good, or will hopefully do a lot of good to give internet to these places. And I think, people can sort of appreciate that a little bit more. But I also think that, SpaceX has done a lot of stuff of late to give, like the trajectories right after launch, or the vectors and stuff to say where satellites are going to be. And I feel like from what I've seen, they've sort of brought up concerns, and a lot of what SpaceX has done of late, they've tried to, work with TS Kelso and people like that are trying to keep the skies a little bit cleaner, and more so with like the sun shield and the albedo, like the paint that they use on it. So they're it's SpaceX is build, fly, test, explode, and try testing again. And so I think that this is sort of just a process that will have to be worked through to figure out, what works the best. Is the sunshade going to work? Is the paint, going to work the best? And I think it'll work out in the end.
Yeah, again, I wouldn't. Maybe I'm a bit older, a bit less optimistic, perhaps, because the other issue that we have to face, and when we bring Kate back in on this, is space debris. The fact that we're going to be launching many objects into a fairly crowded piece of space, and it's a responsibility, of course, on the operators to make sure, when the satellite, should be at least, and it's becoming a responsibility, to bring them back down again. So how much in the design of what we do, of course, there's more to do with satellites than rockets, but bits of rockets end up in space as well, upper stages and so on. So, how do you factor that aspect into what we do, trying to keep space clean, so that because it's a finite resource. Weirdly, it's big, it's empty, but not actually as big and as empty as people might think.
Yeah, I mean, space is really, really big, but like you said, there are certain orbits, kind of highways, where lots of satellites want to be, and that's where you get the congestion, so to speak. And it's not necessarily the satellites, operational satellites, that are causing the issue, but it's the dead satellites, or it's the bits of debris that are floating around. And specifically, for example, on the ISS, the International Space Station, we have to be careful of human life, so they have to make sure that space station is going to avoid any debris that's coming their way. And in Europe, we're a bit of, and this is again, it's a bit of a trade-off, because this is constraints. And like you say, for reusability, you have to consider, well, I have to have fuel to come back down again, and the same thing for for space safety is, what do I do with my upper stage at the end of flight? And then I have to save some performance on my upper stage in order to put it in a safe orbit or to bring it down again. So then I'm losing performance on my rocket. And in fact, in Europe, we're quite a forerunner here because we launched from French Guiana, which is a French state. So France is the launching country officially. And then we have something called the Loi Spatiale, the space law, that now defines what we have to do with the upper stage and the constraints we have on cleaning up after ourselves during launch. This applies to launches today, and it applies to the rockets we have in development, like Ariane 6 and like Vega C. And so for the example, the classic is the upper stage. The other bits of our rocket will fall back down to the ground. The upper stage can stay in for up to 10 to 15 years. We have a constraint. Upper stages have to be pacified, which means we empty them of all their propellants, so they're not going to explode at all in space. Then we put them on, either we bring them back down to the ground, or we put them on what we call a graveyard orbit, where they're up in space still, but out of the main orbits, and that we know that they will naturally re-enter after a maximum of 15 years. Because of air drag, atmospheric drag will bring them down again.
Right. So let me, go on.
Providers like Rocket Lab and stuff have been, good stewards of space in that way too. So it was cool to see and photograph their launch, but it's also exciting to see that they're, being good stewards of the planet.
This is something everybody has to do it, and this is the point. It is a bit of constraint on your system, on your launch system, and if you're doing it and nobody else is doing it, then you're kind of losing performance for nothing. But if everybody's doing it, then it's the playing field is fair, and everybody then is more incentivized to keep space clean.
Yeah, I think that's interesting because I was in a meeting very early in the year before the lockdown, where we had representatives. It was to do with the mega constellations and light pollution, but there were representatives there from SpaceX and from OneWeb, and it was quite interesting to see how they were pitching not only the light pollution aspect but the debris management aspect. And they're all, but they're in a market, and they're commercially. Of course, OneWeb has gone bankrupt since, so you can't argue they're not in the same market. But this going, as we go forward, there will be people competing. And the question is, where do you cut the corners, right? In order to compete on price, what things are you not going to do? Like say propellant to bring things down, and where do regulations come into that? So, if we look back at the US now, there's sort of moves to, open up access to space exploitation, commercial exploitation, and these things which are maybe inside the current laws or maybe their interpretations. Do you think, from what you've seen in the last couple of years, Trevor, that because you've traveled around the world and you've seen different people playing in this market, do you think there's time for better regulation before things do get ahead of ourselves, or will that stifle innovation?
I think just like the astronomers working with SpaceX to develop the light pollution stuff and sort of cater to each other's concerns. I think there's always stuff that can be done to because business, I feel like, in space is only going to grow. So I think hand in hand, it'd be good if the regulation and the commercial market sort of worked to build each other up along the way.
And the interest, the interest of the commercial market, because space debris doesn't, avoid your satellites. Even, it can happen to anybody, and you even if you leave one of your satellites and then that destroys another one of your satellites, you're kind of losing out. So there is a definite, interest gain in everybody keeping space clean.
Yeah, there's definitely a coronavirus metaphor there somewhere, right? It's not only your satellite you're affecting, it's everybody else's if you're not responsible.
Each satellite affects 2.5 other satellites.
Yeah. What is the R factor for? Well, because we know it's the Kessler syndrome, and it's the point at which when we get there that it runs away extremely quickly. And so in some ways it is like a pandemic. There's an exponential growth. And if we get to that point where, as you said, either an upper stage explodes or two things cross over and collide, that can run away very quickly. It doesn't just affect those two satellites; it can explode.
And
go ahead.
Stifling creativity can also create new systems and new markets, which is going to clean up space. And we have new companies, startups now considering this, having missions testing out, going to take up bits down from space, or there's a possibility of reusing, having an upper stage. Well, I've got a bit of fuel left, well then I'll go and use that to grab something else and bring it down. So there's a whole new ecosystem now created around the potential of cleaning up space, and it's something that people may be willing to pay for.
Yeah, exactly. And not just bringing stuff down, but sort of maybe going and grabbing onto a satellite. I think I've seen before, and going to push it sort of back where it's supposed to be and continue its life too. So
Well, please, by all means, correct me if I'm wrong, but did I not see something from the ESA side about a proposed space harpoon, which, to me sounds like the coolest thing I've ever read. Just, I mean, I guess just to, helm a ship, firing harpoons at space debris sounds like the best job in the world, really, because that's what immediately came to mind. But I guess, as you say, it is spawning a lot of really good and innovative ideas as well.
Yeah, ideas for catching satellites also, because we are talking about satellites that are potentially out of control. So they're spinning, they're not being maneuverable anymore. So it's all these ideas about how to catch these kind of satellites, and they're just amazing. It involves harpoons, it involves nets, it involves flamethrowers, trying to get them back. So you can really have good fun designing those kind of things on a very solid scientific basis.
I think the metaphor is interesting, though, isn't it? Because if you think about public sanitation and the fact that the bin men go by, there's money to be made out of removing other people's garbage. But of course there wasn't originally, all right, because people say, why would I do that, right? I mean, it can just be pushed somewhere else. It didn't get recycled. You just kind of out of sight, out of mind. So at some level, you've got to come to that realization that if you're not cleaning space proactively, it's going to affect you in the end. So you can't sort of ignore it and say, well, it's somebody else's problem. So this sort of incentivization, maybe it has to be a bit of regulation, but it will also become incumbent on the operators to say, this isn't good for my business to leave my stuff there, because other people will just be able to leave their stuff there. So I'm intrigued to see how that really will play out in the next 10 years, because we talk about mega constellations only, the ones in low Earth orbit. I think FCC licenses now just in the US have been applied for over 100,000 satellites at the recent round. And how many active satellites do we have in low Earth orbit at the moment? Is it a couple of thousand? So
3,000 or 4,000 or something like that.
Yeah, unbelievable growth. And like with many other things, the problems that will come from scale are not necessarily linear problems where you double it, it gets twice as bad. They can run away very quickly. And as we've learned, again, coronavirus and many other things, climate change, you need to think as far ahead as you can, because once you get in that situation, it's almost too late, right? The proactivity, and we're talking to people living in 4 different countries who've seen 4 completely different, well, not completely, but largely different approaches to controlling coronavirus, and yet it's the same virus. We're all human beings, so what's going on here, right?
Mm-hmm.
There are different approaches. There's just to say, there's the other point here, going back to what Trevor was saying about also kind of picking up a satellite and moving it out. So the next Ariane 5 launch, which is going to be in normally end of July, there's actually a special passenger on that. There's 2 communication satellites, and there's something called MEV2. I forget the exact multi-purpose vehicle. It's a kind of mini sub-satellite. It's a propulsion system of a satellite, and that's going to be launched, and it's going to go and fix itself to an existing television satellite, and then be that satellite's propulsion system, and so extend that satellite's life for another 5-10 years. And again, this is opening up. One has already been launched, and this is the second one being launched now, and it's opening up this whole different market of reusing, which is very fashionable. We're reusing, we're recycling, we're upcycling these satellites and making the most out of what is in space already.
So I want to just shift gears really quickly, because it's come up a couple of times, because this is such an exciting moment, but also, worldwide. I mean, just like we are living through a pandemic. And so I just wondered how COVID has actually affected, a lot of these launches, many of which, will have taken years of planning and so on. So there is a launch this Thursday. How is that affected, or how is it unaffected by such a profound historical moment?
It's definitely been affected. It's been delayed because we had to close down the launch base in French Guiana because of the lockdown in France. We said France has had a very severe lockdowns in order to kind of cut the virus at the beginning, so everything was shut down. We obviously have to keep people going in for safety reasons. We have explosive things on site, but the minimum crew were there. And as soon as we were allowed to reopen, then a lot of teams come out from Europe, flew out, and they had to do a 2-week quarantine before they were allowed to start working again. So we had to just take all of this, the lockdown plus the quarantine, into account, send the teams out 2 weeks earlier, have all of this protective gear in place. I mean, luckily for satellites, we already have all the protective gear, so it's just kind of wearing them outside the clean rooms as well now. We're used to having these kind of equipment. Otherwise, it's not exactly business as usual. We've had to make some adjustments, but you know, the rocket launches must go on, and that's exactly what I want to do.
Yeah, and just to point out that, of course, French Guiana has a border with Brazil, and with the growth of coronavirus there, it's a thing we're having to take, you know, very seriously at the moment. But Trevor, you've been driving backwards and forwards across the US at the moment, and of course, I think many of the launches were, let's say, deemed critical that they could continue. Did you see a difference in the launches you've witnessed in the last 4 months or so in how people were, you know, at the sites, whether it's the public? I mean, of course, there was DM2 recently, and I must admit, I was watching pictures of that and thinking, do you guys know there's a pandemic on? I mean, the crowd watching, right?
Absolutely, yeah. It's a bit in Florida. It sort of feels like normal, you know, whether that's good or bad. You know, I guess I don't know, but of late they've fared pretty well, at least here in Brevard County. You know, in other parts of Florida, you know, not so much, but definitely at Demo 2, like you were talking about, there was I think like 700 media, at least on sort of the media side of things, that wanted to attend the launch, and we're sort of vying to be here, and only about 90 were able to actually get approved and come. So it was a privilege for sure, and publicly, you know, people sort of gave warnings of like Bridenstine was saying, maybe, you know, just stay at home and watch this one online. But the crowds, they definitely came out.
Yeah, I mean, saw pictures on the bridges and so on. You know, of course, they were off-site, so they could do what they want. But it, yeah, it did. Because some of it we know, telephoto lenses can compress crowds quite effectively. Just to point out, since we've got both got Ariane 5s in the background, of course, the big launch for Ariane 5 next year is the James Webb Space Telescope, and you know, hugely ambitious project that's taken decades. I've been involved for more than 20 years, and the development of missions has been affected, perhaps to some extent, more than the launches, in as much as, you know, payloads are being integrated, people are working, and JWST has just seen an official launch slip of, we don't know yet, you know, a few months from spring, maybe to autumn next year, because, you know, you've got to have huge teams of people, thousands of people, and many tens of people in the clean room. And did you, again, on site, because you know, it sounds crazy, you've got long lenses, you can see what's going on the other side of the fence, so to speak. Did you see a change in how people were working towards integration at all, or was it all pretty distant anyway?
I think you know, I would imagine that they are, because they're dealing with the hardware, at least referring to Demo 2. They're dealing with the hardware the astronauts are going to climb aboard and be surrounded by. So I think, you know, just because of that, because they wouldn't want to transmit it to the space station, they're probably, you know, they're in the, like Kate was talking about, they have all the gear normally, but they probably took, you know, the extra step or 5 to make sure that, you know, everything was totally sanitary.
Yeah, the very idea of getting the, you know, SARS-CoV-2 on the space station. I mean, what are you going to do at that point, right? So
yeah, nowhere to go otherwise. But us media on site, we were required to wear masks and keep our distance from people, and limiting the numbers of media in attendance, I think definitely, you know, helped keep the distance.
Right.
Well,
so, yeah, sorry, go on, Alex.
Go ahead, Mark.
Well, I was just going to say, so Kate, you work on future launches preparation, on the future development of rocket motors. And you were just talking before we came on that, you know, certain things are much harder in lockdown because we're at home, and certain IT systems are maybe not quite, you know, working the way you'd hope. You know, you can't get access to your classified documents anymore because sort of something's gone wrong. How do you think we're going to stay on track in this time? I mean, you know, you and I both work for ESA. We hear the daily briefings. We've been pretty effective, I think, actually, as an agency, in both controlling, you know, keeping people safe, but also continuing business. How have you seen that affecting what you've been doing in the Future Launches program?
In fact, the first thing we have to say is, you know, you have to consider that if we had this lockdown even 10 years ago, I don't think we would be as efficient as we are today, between all the different tools we have and the internet connection, everybody having decent internet at home. And we've actually been able to do a huge amount from home. And there's certain aspects we haven't seen any difference, or even it's even been better because we've had this time to get through a lot of technical documentation, really read the documentation, have discussions about it, and not be distracted with, you know, too many other kind of meetings. So we've actually managed to take this time to go through documents, make a planning about what we need to do. We've had to have stop certain activities. So, for example, we had test of a 3D printed engine was planned in our test site in Germany at the beginning of April. We had to delay that. We were not able to do that. But then we had the time to kind of really discuss what had happened and what we're going to do next, how we're going to move forward with this project. And as soon as the test site opened, we were ready, we were in there, and we performed our tests, and that went really well. So I think we're actually going to be able to, we're not going to see huge impacts on our future projects because we've got, we've got our eggs in so many different baskets. We've got so many different projects going on at one time. And because these are future projects, sometimes they go faster than you plan and sometimes they go slower. So this kind of pause has enabled us to sit down and think and read documents and even just move off faster now that the lockdown is lifting. And the fact that our projects are all over Europe. So Germany was lifted a little bit earlier than France. So our test site in Germany was able to open up before we were working in France. And we have people working in Sweden and Belgium and Spain and Italy. So we were able to kind of modulate our projects because they're all over Europe and different things were going on. Something was always going on somewhere.
It's a fascinating, aside, of course, but I guess it just goes to show that, it's all about adaptation, I suppose, and, innovation. And, I want to just like just to switch gears again, something really stimulating comes in. I should acknowledge and say hello to everyone who's watching from around the world. We have people from Finland, from Washington, D.C., and the list goes on. Ren Paran has a really interesting question for Trevor, and I guess this is almost around the culture of rockets and so on, because of course, I mean, just like they, beyond launch vehicles, they are iconic, and in terms of the iconography of the space age, I mean, just like there is nothing that more instantly comes to mind than all of that. And it seems to have spawned, Trevor, I suppose, a bit of a culture around, people who go down to take pictures and so on. And, we've used Uber to describe rockets. We've used concerts to describe what happens at launches and so on. And I suppose one of the things that happens when I'm going to gigs is I see a lot of familiar faces. I wonder if there's a similarity with what you see on the ground.
Yeah, definitely. There's almost like a little community of people who have sort of adopted the addiction, as Mark was talking about earlier, and we're all sort of on the same track of loving capturing all of the historic moments and experiencing them together, and going out to eat afterwards, and making friends. And it's definitely something. I thought I was coming here for the rockets, but the other half of the pie is all the people and the friendships you make along the way, for sure. So there's like the SpaceX and stuff, there's some fanaticism to it, but it's all in good fun, I think. Everyone's single.
Like photographers in the pit, are you guys jostling for the same angle sometimes? I mean, someone pulls out the telephoto lens of doom and everyone else goes, whoa. I mean, what's it like? Is it a bit competitive?
We can't compete with that, yeah. So we all set up cameras in the proximity of the launch pad, from only like usually 4 or less locations. And outside of the pandemic, there's usually 40 or 50 people there, just for photography, not just media as a whole, sort of 90 media. We're all sort of vying for similar spots, and everyone sort of takes a different approach. Some people get a little closer to the ground. Some people are trying to go to the flowers over here, and there's some palm trees over there. So like, it's a little bit of a variety, but that's where the artistic eye comes in, and everybody can sort of get a little bit of a different shot, even though you're so limited in your locations.
So let me ask 2 questions, one provocative and one more serious. How many women are in the club? How many women are doing this?
It's about 3/4, I would say. Maybe 80% men.
Men, yeah. Well, it's good. I mean, it is not 100%, so that's good. But the more serious question is, so obviously from a distance, you're with your camera, you're taking the shots, but there are also the opportunities at the launch sites to go in and install cameras, remote cameras, which will take pictures at the moment of launch. And then, of course, you don't know what you've got until you go back in maybe a day later or a couple of days later. And, there's this anxiety. Of course, sometimes the cameras themselves get damaged. So how do you prepare for that? Because, even technically, how do you make those pictures? How do they happen? They're far enough away from you that you're not controlling them in real time.
Yeah, so other than a camera on a tripod, there's a little sound trigger that sits on the top. It's called a myops, and it basically, you set the threshold of, how loud do you want it to trigger for, and you hopefully set it below the trigger of a raindrop or a little light tap on the box will set it off, but above, below the rocket, but above the raindrops. So the rocket will be sort of the only thing that triggers it off, and they're quite loud. So that threshold doesn't have to go very far before it gets set off.
So you'll just set in motion at that point. You just, the highest speed the camera will take exposures at, and it runs out of buffer at some point, and that it's done. And you come, as you say, you come back a day later, and sometimes I imagine, you won't place it directly in the rocket trench, but you must come back. You must have lost some lenses along the way at some point, I'd imagine.
Yeah, the launches here in America, and like Electron, and most of the ones that I've seen, other than Ariane 5, are fairly slow off the launch pad with like a low thrust to weight. So you could shoot at it like a lower continuous speed, but I've learned my lesson now. So if I go back for JWST or for a Vega someday, I gotta set it a bit faster, because there's only so many seconds before it clears the tower.
Right. So yeah, go on, Alex. I've got a bigger question to ask in a second if you've got one.
Oh, no.
Maybe a question from the...
Yeah, I just thought it might be we could bring in a couple of our
yeah.
viewers. Very quickly. It's an interesting one. The first one is really a great one, which comes from Annabelle. Of course, we've been talking about what it all looks like, but what does it smell like? And do you actually get an aroma of just singed everything, or what's it actually like there to kind of put us into space?
Yes, the answer is burnt everything. I remember once in French Guiana there was a launch at Ariane 5, and it was kind of like at the beetle hatching season, and so this rocket went up, and the next day we just had thousands of burnt beetles on the ground, because it takes everything to go. It's really, I was just going to go back when we talk about when you see a rocket launch, and I really enjoy is the discussion afterwards. You always hear it. Was the light more impressive, or was the sound more impressive? Because the sound, like, it comes through in a waves and it shakes through your belly. It's this deep, deep rumbling. And the light, especially in a night launch, it's like the sun comes up again. It's a whole new day. And generally, when you're in the public viewing sites again in French Guiana, you're not close enough to get that smell. But we do get it. And it's a really interesting question. Like you said, the next day we have to do cleanup operations on the launch pad, because it's the next launch needs to get ready. And we've had this enormous rocket. We've had aluminium and plastic burning onto the launch pad, and then we have to clean up the systems. We throw up all these chemicals, water and chemicals, onto the launch pad to kind of to pacify everything and make sure that we can then go back. And it has this very specific aroma. We have that kind of post-launch day aroma around the launch base of this hot metal with these kind of more cleaning chemicals being kind of wafting all in the air.
I think the best way I've been able to describe it smells like a car battery almost, just sort of like acidic, and yeah.
Yes,
it's
metallic smell.
Yeah. Good one. And we have another one from Julio. For I guess specifically for Trevor. So how do you not burn up? It looks like the plume is absolutely enormous. So I guess, how far away are you from these things when you're kind of standing there? Because I imagine you don't really want a front row seat at these, do you?
We give our cameras the pleasure of being burned up from a couple hundred or maybe as far as like 1,000 feet away, but we're usually at least 3 miles here in Cape Canaveral, and I think at Toucan in French Guiana we were about 5 or 6, I want to say. You're
about 5 kilometers out, I think, at Colibri from the Soyuz pad, if I'm right. But so about the same distance, 3 miles.
Yeah. That's cool. So I mean, we're plenty outside the exclusion zone, and away from the smells. Luckily, we get to experience those the next day instead of on launch day.
I'm sure you've seen lots of videos, of course, of the guys in Kazakhstan. There's one very famous one which I've used the sound from. I mean, the video itself scares the hell out of me. But somebody's with a mobile phone taking a picture of a Soyuz launch.
Yeah,
and
they're looking up.
yeah, and they just move up, and we figured out by trying to work out what's the blockhouse they're standing next to, and it's 150 meters from the launch, and it's like, oh, it's good sound, but yeah, you have to be. Of course, it obviously doesn't do any damage if it goes well. The real problem is if it doesn't go well, you're in the wrong place, right?
So I wouldn't want to be there for sure.
Yeah, I think there's a sort of, I mean, you're wearing a Russian flag there on your sleeve there, Kate, and there's kind of a macho thing, I think, a little bit about the stuff out at Baikonur. How close can you get? Not necessarily, from everybody visiting, but from some of the guys that work on the range.
Yeah.
This is actually, I'd say, one of my favorite rocket memories this is a T-shirt from the second Soyuz launch in French Guiana. And in fact, I worked on the first and second Soyuz launches. So we bought this mythical, really is close to the heart of all rocket scientists, launcher to French Guiana. We built them a whole new launch pad, and we actually adapted it to be able to do vertical integration of satellites. We had this whole new mobile gantry that didn't exist in Russia. And I worked on the first launch, the first time this Soyuz launch was being launched from European soil. And there's an operation you have to do at 50 minutes before launch, which is to remove the ventilation. All the satellites are ventilated with cold, dry air. They don't like French Guiana and 100% humidity air. So we have this ventilation, but 40 minutes before launch, you have to take them off. And this is an old school Russian launcher in Ariane 5. It's kind of automated, takes itself off. And in Russian, for Soyuz, we have to go and physically take this ventilator off. So you have to go up to the top of the launcher in this mobile gantry. All the electricity has been cut off because you're 40 minutes before launch. So you have to walk up the mobile gantry, take this ventilator off, and then basically run as fast as you can down the mobile gantry and back into the launch base, where you have a little flag and you have to give them back so they know that everybody has come back in. And this really is, it's by the time you've done this, it's half an hour before launch. And the rocket is, again, because it's so humid in French Guiana, then there's this cold gas coming in, and there's this ice being formed on the rocket, and all this billowing clouds of ice all around you. You're kind of running as hard as you can away from the rocket as it does this to get back in. But then, obviously, you are safe. You go back into a very safe, secure bunker. What I was going to say for the launch teams, we're about 1 kilometer or 2 away from the launch pad, but in bunkers that have been specially built to survive a rocket landing on top of them.
So the thing we've been talking about here, I mean, and that kind of brings me to the question I had from a bit earlier on. The Soyuz is about as old as it gets. I mean, it's been developed, but it's developed from the launcher which launched Gagarin into space, nearly 60 years ago now. And for all of the advances for the European rockets, the Saturn V, and now the reusability, and even things like Starship when they come along, in the end, they're rockets. Right? They kind of do the same job. So let's cast our minds forward, because one of the things we talk about a lot in Space Rocks is science fiction. But some of that science fiction is so far out, it's not, faster than light ships going through black holes. Fine, great. Let's not talk about that. But there are things in between. So things, space planes, for example, things which can launch horizontally off the ground, go into orbit, and then return and land. So not like the shuttle, a reusable aircraft, so to speak, that goes into space. And we're involved in that. We're involved in helping on the engines there. So give me why is that so hard? Why haven't we built one of those things, right? Come on, it's 60 years later. Why haven't we just built ourselves a decent space plane, which can take off like a plane from the ground?
It's a little bit like I was talking about earlier. It's this staging principle. It's that we need to get up to 8 kilometers a second. And by the time you've got enough fuel to get up to 8 kilometers a second, then you have this huge structure, and then you just basically can't get it off the ground. This is, like you say, the goal is this single stage to orbit, just take off and then fly. And we've been making advances. Like you say, we're working on the engine with reaction engines in the UK on what would be a space plane, but we have to work on, we're at the limit of the material science. And I remember doing some studies years ago, and we saw the materials we needed to be 10-20% lighter than what we have today in order to be able to have a structure that was big enough to hold the propellant, but still light enough to get off the ground. So there is, these engines are incredibly complex. We're trying to optimize the engine using air breathing in the beginning and then moving into the rocket, because we need, at some point, we need the rocket fuel because we're out in the atmosphere and we can't breathe the air anymore. So it's having A, this engine working properly, and then B, having the structure around it that means that we can fly up, and then B, come back down again. And those are different constraints. We end up getting, it's not easy to get up. It's really not easy to come down again.
Right. So describe to me, just because it's one of the most fascinating things about these air-breathing engines, is that as the air comes in, because you're traveling very fast while you're still breathing air in the relatively low atmosphere, the air is incredibly hot, just gets compressively heated, but it has to be reduced down to cryogenic temperatures, so changing the temperature by many hundreds of degrees. In how much space? In kind of centimeters, right? I mean,
I think it's something. They have 10 or 20 centimeters, something like that. And like you're saying, it's going so fast. So that distance of 20 centimeters is, it's milliseconds that it has to go through. And this is, like you pointed out, it's one of the key parts of this engine. It's something that's been worked on. And they have a whole new design. And again, where these new manufacturing techniques come in, where we can create these tiny little thin coils that we have thousands of them, so that the air comes in very, very hot on one side. And then, 10 centimeters later is cooled and is ready to go into the engine.
Yeah. Because, I mentioned Starship there. Starship is it's an innovative single stage to orbit approach in the sense of having loads and loads of engines. It's got the Starship. Well, I forget the nomenclature. There's the launcher part. Yeah. And then there's the Starship on the top of it. And, sure. We've seen them all blow up. They're being built, but they're innovating by testing, as you said earlier on. But again, it's sort of kind of more of the same in a weird way. And I am wondering, between the two of you, what do you think? You think is there a paradigm shift coming, or are we going to be launching rockets for the next 100 years to come in the kind of way we are today? Broadly, maybe cheaper, maybe easy to build through 3D printing, but it's the same principles.
I'll take that first. I think the baseline is going to be the same today for a good few years. So it's going to be what we've got now, but making it, like I say, better with 3D printing, making it reusable, using different fuels, so LOX, methane. We're working on the reusable engine like Prometheus in Europe, using LOX, methane to make it a little bit more routine. We'll go up into space, we'll come down, but on the basic principles we have today, just kind of doing them, a little bit better. And things like the space plane we're working on with reaction engines, I would love it to work out. I think it's a little bit longer term, so a good few tens of years until we can get something operational. So there's still a lot to do. I think we're working on what we've got now, and it's going to go into space. We're going to rely on it, and I think it's going to become more routine. So we're going to do more and more launches, and we're going to have big ones and small ones and all different satellites. And that's going to go for a while longer. And then in the meantime, we can work on things like space plane and also work on engines into space. So going further out into the solar system and trying to get people on Moon and Mars and trying to get them back again.
Well, this is a really interesting thing, and it's actually culled from something sparked in the live chat. We are perhaps looking at a point in the the not so distant future where perhaps we may not be just launching from Earth, right? Some of these plans to use the Moon as a staging ground. That is a stunning proposition. How far away is that, and how does that change things in terms of building and sending rockets up?
So, we've already obviously launched from the Moon. That's what, the United States, when they went to the Moon, they did come back from that. So we know that we can launch off from the Moon, which is easier. As you know, the heavier the body, the planet you're lifting off from is, the harder it is to get off. The Moon is much lighter than the Earth, so we actually need a smaller engine, a smaller rocket to get off and back to Earth. And Mars is really interesting because, again, it's lighter than Earth. So we need a smaller rocket to lift off from Mars and come back to Earth than we do to get to Mars from Earth. And there is at the moment, ESA and NASA, so European Space Agency and NASA, are working on a Mars sample return. There's been some publicity recently because NASA gave a contract, I think, for Airbus for the rover. We want to launch in, I think, 2029, a rover to Mars that will go and collect soil samples and then lift them back off from Mars and bring them back to Earth in 2032 for analysis. In that case, we're talking about relatively small launches from Mars. We're talking about bringing back a few kilos of samples. But I think, again, Trevor can probably talk about this. Elon Musk and SpaceX have a big idea about really taking people to Mars.
Yeah, I mean, their goal is to take up to, I think, 100 people at a time, which is, that would be wild to not only see, but photograph and to be a part of society, really.
Of course, the key difference there is, and the critical thing is making the fuel in situ, right?
Yeah.
Because when we lifted off the moon, it was with a rocket that was sent, with fuel, and the Mars sample returner will be a rocket. But you've got to live off the land. You've got to get oxygen. You've got to get oxidizer and fuel. And those are the sort of real challenges, right? How, what are you going to get from Mars? Is you going to make methane, right? Because there is a lot of carbon dioxide. It's a very thin atmosphere, but it's mostly carbon dioxide. So that idea of creating rocket fuel in situ brings in this whole sort of industrialization aspect as well. What kind of machinery, how long will it take you before you can make enough fuel to come home? So I think there are colossal challenges, in principle solvable, but it's not just take a rocket there, come home. You're going to have to you've got to build a fuel plant. And if you think about the rocket sites where you've taken pictures, Trevor, and where you've worked, Kate, there's a lot of infrastructure. I mean, I don't actually know. I mean, a very simple question: where is the liquid oxygen and hydrogen made for Ariane launches in Kourou? Is it actually made on site? Are there big splitting plants there that just take water and make it? It's not brought in from Europe, I don't think. I don't know.
Well, the helium is brought in, but otherwise we have plant. Exactly, we have plant. On the back of your photo, you can see a line going up to a small white shelter, and that's, I think, the oxygen. Yeah. But we have a plant on site it actually makes oxygen for all of French Guiana, because liquid oxygen has medical uses as well, and liquid hydrogen, which is a bit harder to make. It's all made on site, and also because then we have a very small transport. It's transported 10 minutes down the road. It's 2 kilometers and it takes an hour, because you really don't want to crash a container full of liquid hydrogen. But exactly, we have specific production on site, and we're increasing the production. We're trying to find ways of increasing production, reducing the cost as we ramp up with Ariane 5 and Ariane 6 coming in.
So yeah, before I realize we're past the hour, and maybe Alex has other questions. So talk to us briefly about Ariane 6. Why, Ariane 5 has been successful. We've had more than 100 launches on it, if I'm right. And why a new one, right? You talked briefly about the fact that it was designed to carry 2 satellites, typically to geostationary. Is that market changed? Why Ariane 6? Or is it cost? Is it which parts of it? Because we probably know, most people know more about Falcon 9 in a sense than they know about Ariane 6 at this point.
So to say Ariane is the kind of, between Ariane and Vega, these are the 2 big European launcher families we have operating in French Guiana, as with Soyuz that we bring in from Russia. And we have Ariane 5 operating today. As you say, it's been a very successful launcher. We have had over 100 launches. But as we were talking earlier, the commercial market has been changing. In Europe, we launch European satellites, governmental satellites. We also launch a lot of commercial satellites, and so we're dependent on the commercial market to keep our launch rate up. And we could see that was changing, and we could also see, especially with what has been done in the US, that the launch prices were going down. And Ariane 5 is a great launcher, but it's a bit of a Porsche of a launcher. It works perfectly, but it's very, very complicated. It's very, very high tech. And especially with all the lessons we learned from Ariane 5, we said we need to make a launcher that is modular, that can react to the different market systems, and take all the lessons we learned from Ariane 5 to make something that's actually going to be cheaper to launch on Ariane 6. So what we have on Ariane 6 is we've ended up with 2 versions of it. So we have a version with 2 solid boosters and a version with 4 solid boosters. And the version with 2 solid boosters will launch only 1 satellite, and that will be more or less dedicated to institutional missions. So we're launching government weather satellites and Galileo satellites and missions for governments. And then we have the 4 booster version that has the performance that can launch 2 commercial satellites or a large logistics vehicle or something like this. And we've taken all the lessons learned from Ariane 5 and also from looking around the world. So for example, Ariane 6 will be assembled horizontally, which is not the case for Ariane 5 today, but it is the case with Falcon 9.
Yeah. It's been cool to see when we were down there for the Ariane 5 launch for VA250, we got to see the sort of Pathfinder horizontal integration of the main stage of Ariane 6 and the trenches that they've dug are just spectacularly large.
Yeah.
Because they're holding both the main stage and the boosters now in just two versus Ariane 5. You can kind of see in the photo, it sort of goes back with the main stage and out with the EAPs. But now they're a little bit, it seems like a little bit larger to hold the volume of the main stage, splitting out both sides as well.
Yeah, and they have to be adaptable. All the ground system has to be able to manage the two booster version and the 4 booster version. And all of this system has been put in place that we can be flexible. We're going to have two launchers being assembled at the same time. You can have a very quick turnover rate. And in terms of learning on the operations, so Ariane 5 today, a full launch campaign is about 30 working days. And I think we want to get down to around 16 for Ariane 6, so we can really increase the launch rate, be more flexible for the market, and also reduce our costs.
How do you say EAP in French?
Étage d'accélération à poudre.
Fantastic. Wow.
We have to point out that Kate is actually sitting in Paris, so that if she
Yes.
if she didn't manage to do that, she would have been evicted from her flat.
So we're coming up to the end. We have a specific question, which I guarantee will induce a few eye rolls, perhaps, but I think it's an absolutely fascinating question. It's absolutely brilliant, and it should be addressed. And another one, a big collecting one, as we come up toward the end. And so I'm going to frame this because, this always comes up, probably more frequently in science fiction chats than anything else. But why go through all the trouble when you can just build a diamond-encrusted cable and have a space elevator, right? That takes you from the ground up into the orbit, and it is one of those things that, we talked about generation ships in previous uplinks and other things. And, it's a great dramatic device, I take it, but from an engineering standpoint, probably not in immediate view.
We're not there yet. No.
Yeah, I mean, I like the way you phrased it, diamond encrusted. I think that's probably about the last thing it is. It's made of single strands of diamond, maybe, but yeah, I mean,
once we get, I feel like I've seen carbon nanotubes going, then maybe that would work. But lots of the misunderstanding, at least in my part too, before I sort of learned what was going on, I thought you just go to space. Like I didn't know that you sort of get out of the atmosphere, and most of the work, like Kate was talking about, how the engines are adapted to sort of the atmosphere and the space environment to put it precisely where it goes.
yeah.
A lot of the work is going directly sideways.
Yeah.
So you go up and you see like the sort of long exposure photos, and it doesn't spend much time vertical. It spends most of its time horizontal, like almost 9 minutes.
Right.
Like Kate was talking about. So
there is this sort of weird illusion that we're escaping gravity when we go to low Earth orbit. No, we're just going up and then running sideways as quickly as possible to avoid falling down again. When people look at the astronauts in space, they're not weightless. They're in an elevator falling to the ground.
Yeah.
But going at the right speed sideways, you never hit the ground.
And Trevor, I suppose from your perspective, a slightly less dramatic thing to photograph is just like a thing arriving, going ding ding, and then you just sort of it goes up. And then so a final one, and I'm really curious as to your answers. I think we've touched on it here and there, but it's an important one. We talked about the iconography and the symbolism of rockets and so on. Kate, you're wearing a very cool shirt. And so on. What are your favorite rockets, or the favorite from your perspective from over the years? Because so many of these they're more than just really elaborate devices. There's a romance and a kind of a wistfulness around some of them that have appeared over the years. So what are the ones that come to mind when you think of I guess the maybe you could say the classics or your personal favorites?
I don't know if you're allowed to have a favorite rocket. It's like having a favorite child. They're all different and special in their own way. I have like emotional attachments to the rockets I've worked on. So I worked on Ariane 5, and I did the first launch I worked on was Herschel Planck, and so amazing, beautiful satellites with a really amazing mission. And Ariane 5 as a launcher is really a beautiful launcher. So and I really enjoy the European aspect, the whole teamwork that's gone all over Europe, that's gone on to make that machine and make it get these wonderful science satellites into space. I really enjoy that aspect of it. And then I have a special, I really like Soyuz because I was the first one, I worked on these launches, the first Soyuz launches in French Guiana. And it, like I said, it's such a classic launcher. It's the one that took Yuri Gagarin into space. It's the one that's still taking people into space today. It's launched over 1,800 times. It's, and I got to work up close to it. And it, you know, it looks like the plumbing in my nan's bathroom, but it still works.
Fantastic.
Yeah, I think I would probably echo the same thought as you know, I don't know if you're allowed to have a favorite, but my, you know, the Falcons, the Heavy and the Falcon 9 have really allowed me to do what I do photographically, and I've made some of my favorite pictures of those. But sentimentally, also the Soyuz, for me, going to see that in Baikonur was just you know, having watched all the documentaries and all the, you know, the history between the U.S. and Russia, and being able to stand on Gagarin's start, you know, the day before launch, and see it, you know, roll in and go vertical, just was an otherworldly experience, and something I'll definitely never forget, because that was my first, you know, human spaceflight launch, and knowing that there's precious cargo at the top other than just satellites that we could, you know, rebuild. It would be expensive, but, you know, it'd be possible to replace. So.
Yeah, I mean, I fully support, you know, both of those, you know, but I think the one thing which is interesting, because I think it also speaks to how people's view of history changes depending partly on how old you are. I mean, I'm not going to pick the obvious, which is Apollo, but the Saturn V, but I'm going to pick the shuttle. And I think, you know, I think that's remarkable, that era kind of, it's a little bit like, you know, Concorde coming and going, right? The fact people will say it was a death trap, you know, it killed people. Yes, it did, you know, but space is like that, I'm afraid. I mean, you know, we've not got any system to the point of safety where rockets are safe. But then was that, for me, very slightly personal story was that when it launched, the first one launched in 1981, I was lucky enough for the landing to be at a place called RAF Cranwell, which is where young RAF pilots trained to fly. I was there in the RAF, but I was at Cranwell on the day. I mean, there were about, you know, 100 young pilots just training, and they'd all made mistakes. They were all tyros. They, you know, they were not people who were flying fast jets yet. They were all flying planes. And the shuttle came to land with Bob Crippen and John Young. And, you know, Young had been to the moon and Crippen was the young guy. But it's a flying machine. It actually came in. I can't really do it on Zoom because my hand will disappear. But they came across the runway at Edwards, and they, you know, they flared the nose. And I was a pilot, and I said, oh God, you know, they just put the thing down. And they held the nose up for so long, and they just slammed it into the floor, the gear at the front, and everybody in the room cheered because every single one of the people in the room had done exactly the same thing, which is smash the plane into the floor rather than
Let the nose drop.
Exactly. So yeah, you know, just grease it on, right? You know, we've all been in commercial flights where they've just gone on all through the main gear and the front gear have all gone on at the same time. That's great. And there's the ones where the pilot holds it up and bang, the front. Everybody in the room cheered. So I have a soft spot for the shuttle, and I always will. I mean, it was an amazing machine, and I've actually been hands-on with one of them as well, and actually touched one of them in the orbiter processing facility at one of the last flights in 2010, which was really quite emotional, actually.
I've been lucky to get my private license a couple of years ago from my grandpa, who is an instructor, and that was the first thing he told me is don't let the nose drop.
Yeah, exactly. Well, you know, it's safer that way. It may, you know, the plane will survive it. It doesn't look elegant, but you know, it's
even on the space shuttle, it's still an important lesson.
Yeah.
Fantastic. Well, wonderful answers, and a wonderful note to close us on as well. I mean, not just technology, but I guess you know, vessels for you know, human aspiration. You know, and so I just wanted to thank, on behalf of everyone who's watched, everyone at Space Rocks, Kate and Trevor, it's been an absolute pleasure to spend this time with you. Let's not leave it so long next time, and well, let's find another reason to regroup. I appreciate your time very much. And Mark, it is not the most scientific, but we do have traditions.
Exactly. You know, I'm sure there are many traditions to do with, you know, peeing on the sides of launch vehicle trucks and things. So we're trying to have those in Space Rock. So we have a bit of a hand signal we do at the end. So the Vulcan salute, live long and prosper. So that's space, and then rocks. So
Fantastic.
There you go. Perfect.
fun.
Thank you. Thank you very much. All
Brilliant.
right. One way around or the
Got a little
other.
backwards there.
All right. Thank you so much to everyone who joined us on the live stream as well. Guys, an absolute pleasure to spend this time with you. Thanks once again.
Thanks very much, both.
Work
Yeah.
good in the future.
Yeah. See you
well.
soon. Bye-bye.